We'll cast your mind back to February last year, and you may remember the excitement when NASA successfully landed its Perseverance rover on Mars. This crater that you see here was a lake 3.5 billion years ago. So we are looking at the same environment in the same time period. Imagine standing on the edge of an alien world, a place where no human has ever set foot, yet we have seen it in stunning clarity. Mars, the red planet, once a mystery hidden behind the veil of distance, is now being unraveled piece by piece. NASA's relentless pursuit of knowledge has brought us closer to understanding this barren yet fascinating world. And at the heart of this mission are the rover's silent explorers tirelessly roaming the Martian landscape, capturing history, and sending it back to Earth. These robotic explorers are not just machines. They are symbols of human curiosity and determination, built to withstand harsh conditions and push the boundaries what we know about the cosmos. They navigate treacherous terrain, battle extreme temperatures, and survive dust storms, all in pursuit of knowledge that could one day change the course of human history. Each mission builds on the success of the last, refining technology, expanding our reach, and bringing us closer to the ultimate goal, understanding Mars well enough to one day send humans to explore it in person. Decades of space exploration have led to this moment. The story began with small, clunky landers that provided the first grainy images of Mars. Then came the rovers, each generation more advanced than the last, from Spirit and Opportunity, which first confirmed the presence of ancient water, to Curiosity, which transformed our understanding of Mars' past climate, and now Perseverance, the most sophisticated robotic scientist ever sent beyond Earth. It carries the weight of human ambition, armed with technology designed to search for life itself. These rovers were not built overnight. They are the result of decades of engineering, scientific research, and countless trials. To develop and process involves rigorous testing to ensure they can endure the harsh Martian environment, withstanding radiation, extreme cold, and rocky landscapes. Each rover's landing is a nerve-wracking spectacle requiring precision and innovation. From airbag-assisted landings to the sky crane system that gently lowered Perseverance onto the surface, the stakes are incredibly high. A single miscalculation could mean the loss of years of work and billions of dollars. But when they succeed, they open doors to discoveries that redefine our understanding of Mars and the possibility of extraterrestrial life. Perseverance landed in Jezero crater, a site carefully chosen because it was once home to an ancient river delta, a place where life, if it ever existed on Mars, might have left its traces. The rover's high-resolution cameras have captured images that show layered rock formations, signs of past water flow, and chemical compositions that could hint at biological activity. Every photo is not just a glimpse into another world but a potential clue in one of the greatest mysteries of all time. Did life ever exist on Mars? The importance of Jezero crater cannot be overstated. Its geological features indicate that it once held a lake, making it a prime location for the study of ancient microbial life. Scientists believe that if Mars ever supported life, signs of it could be preserved in the clay minerals found in the crater. Perseverance is equipped with cutting-edge instruments like Sherlock and PIXL, which analyze rock samples at a microscopic level, searching for biosignatures. The mission is methodical, moving slowly and deliberately, drilling into the Martian surface to collect samples that will one day be returned to Earth for further analysis. These efforts bring us closer than ever to answering the age-old question, are we alone in the universe? The Perseverance is more than just a camera on wheels. It carries an experiment that could change the course of human history. MOXIE, a device designed to produce oxygen from Mars' carbon dioxide-rich atmosphere. This is not just a test, it is a blueprint for the future. A step toward the day when astronauts will walk on the Martian surface, breathing air made from the planet itself. It is a preview of the technology that could one day sustain human life millions of miles away from home. MOXIE's success could lay the groundwork for future missions that require self-sustaining life support systems, reducing dependency on Earth for oxygen supplies. This advancement is crucial for long-term space travel and colonization, as transporting oxygen from Earth would be both costly and impractical. Additionally, MOXIE's technology could eventually be adapted for fuel production, enabling the generation of rocket propellant from Mars's natural resources. This advancement would significantly impact mission planning, making return trips more feasible and opening the door to sustainable exploration on Mars itself, reducing costs and logistical challenges. To dream of establishing a human presence on Mars is slowly becoming a reality, driven by innovations like MOXIE, which demonstrate that self-sufficiency on another planet is within reach. No one was sure if flight was even possible on Mars, given its thin atmosphere, just 1% the density of Earth's, and extreme conditions. Yet, on April 19, 2021, Ingenuity took off, hovered for a few seconds, and landed safely, achieving the first powered flight on another planet. This groundbreaking achievement, initially intended as a simple test, has now evolved into something much bigger. Ingenuity has completed dozens of flights, proving its value by scouting ahead for Perseverance, mapping terrain, and demonstrating that aerial exploration of other planets is not just possible but essential. This tiny rotorcraft, weighing just 4 pounds, carries enormous significance. It operates autonomously, making real-time decisions in an environment where communication delays make direct control impossible. Despite its small size, Ingenuity has exceeded all expectations, adapting to challenges and extending its mission beyond its original 30-day test period. Its ability to provide aerial reconnaissance is invaluable, helping Perseverance navigate hazardous terrain and identify key scientific targets. Ingenuity has shown that future missions could incorporate flying drones to explore areas that are otherwise inaccessible to ground-based rovers. This breakthrough could revolutionize planetary exploration, offering new perspectives and capabilities that were previously unimaginable. Future Mars missions could include more advanced drones capable of covering vast distances, collecting samples, and even assisting in human exploration efforts. The success of Ingenuity paves the way for a new era of spaceflight, where planetary exploration is no longer limited to the surface alone. Beyond its scientific missions, Perseverance is also carrying a legacy of human culture. Hidden in its design are symbols, messages, and even the names of millions of people who signed up to have their identities carried to another world. The phrase "Dare Mighty Things" is embedded in its parachute, a silent but powerful reminder of what humanity can achieve when it reaches beyond the possible. The rover even honors frontline workers who battled the COVID-19 pandemic, a tribute from one world to those who fought for another. These details may seem small, but they represent something much larger: humanity's collective spirit and our drive to explore the unknown. Space exploration is not just about science, it is about inspiration. It reminds people that even in the face of adversity, progress is possible. Instead of relying on Earth for fuel supplies, future missions could produce essential resources. Perseverance carries 3 microchips inscribed with the names of 10.9 million people who participated in NASA's Send Your Name to Mars campaign, making them a symbolic part of the journey. These cultural and symbolic gestures highlight the unity of human ambition, connecting people across the globe in a shared dream of discovery. The mission is not just about Mars, it is about the future of space exploration itself. One of Perseverance's most ambitious goals is collecting rock and soil samples, bits of Mars that, for now, remain on the planet but are meant to be retrieved in one of the most complex space collaborations ever attempted. NASA and the European Space Agency (ESA) are planning a return mission that will bring these samples back to Earth, where scientists can analyze them with technology far beyond what any rover could carry. This effort could become the defining moment in the search for extraterrestrial life out discovery that would reshape our understanding of the universe and our place in it. Sample return missions are among the most intricate undertakings in space science, requiring multiple spacecraft, precise coordination, and years of planning. When these Martian samples finally arrive on Earth, they will undergo rigorous analysis using the most advanced laboratory equipment available, potentially leading to groundbreaking discoveries in astrobiology. The implications extend beyond science; they touch on philosophy, raising profound questions about life beyond Earth and the future of interplanetary exploration. If evidence of past life is found, it would challenge long-held beliefs about the uniqueness of Earth and could even influence our search for life elsewhere in the cosmos. Each step forward, from MOXIE's production of oxygen to Ingenuity's flight and Perseverance's sample collection, is bringing us closer to a future where Mars is no longer just a distant world but a place where humans may one day walk, work, and perhaps even live. These advancements mark the dawn of a new chapter in space exploration, one that could redefine our understanding of life, the cosmos, and our own potential as a species.